This lesson covers some extra distance formula examples. Remember that the distance formula is based on the Pythagorean theorem, and it's the distance between two coordinate points on a coordinate grid. So if we are to find the distance between the given points, say for this one here, then here's our distance formula, but really you should be able to determine this formula because it is the distance between the x values, that's your length there, and the distance between your y values, that's your height, say, and then use the Pythagorean theorem to find the diagonal distance, the hypotenuse. So this point is given by point 1, so it's x1, y1, and point 2 is x2, y2, and that's what it refers to, point 1 and point 2. So to find the distance between the x values, the x value distance will be -5 minus 2, or 2 minus -5, and that distance will be squared, as in a squared, plus b squared is going to be your c squared. And that's where this formula is coming from. So just keep that in mind when you're doing it. Now the y distance is 7 minus -3, and we square that. And because that equals c squared, and because our answer needs to be a positive, we can just write c is equal to, or d for distance is equal to the square root. So we've got the square root of -7 squared plus 7 plus 3, which is 10 squared, and that gives us root of 49 plus 100, which is root 149. And you can approximate that by either putting a little dot above or two squiggly lines, and use your calculator. Root 149 will approximately be 12.2. Now that's if they want a decimal approximation. If they want a simplified exact format, then you would simplify 149. So you'd have to know what it divides by. And in this case, I don't think it simplifies by anything clearly obvious, so you can leave it at that. Alright, let's keep going. So we've got distance is, and then we're taking our x's and subtracting them, so 2 root 2 minus 1 root 2, and root 3 minus -root 3. Now, adding and subtracting roots is coming up in a little bit in the next videos, so look those up if you're not sure, but you should be able to see that. If you have 2 root 2's minus 1 root 2, that is the same as 1 root 2, because 2 minus 1 is 1. And then 1 root 3 plus 1 root 3 will be 2 root 3 squared. And we know that when we square, we're squaring, it's multiplying itself by itself, so root 2 times root 2 is 2, and then 2 squared and root 3 squared is what's happening here, so that's 4, 2 plus, this is times, so 4 times 3. So that's the square root of 2 plus 12, which is the square root of 14. Now that doesn't simplify, but you can approximate it or use the symbol, one of those two. The square root of 14 is approximated by 3.7. So that is the distance between those 2 points. However, usually when they give you exact values, then you'd want to answer in exact format. So they don't always specify. If they don't specify, you can offer both. Here are some other examples. So I apologize for this picture coming out not so clear here. So you have a triangle with 3 points, and the question is to find the perimeter of the triangle. So try this question out on your own and then just check if my work is works with your work. Alright, so the strategy I'm assuming that you are developing is that we need the distance here, the distance here, the distance here. So let's call this distance 1, this distance 2, this distance 3. So distance 1 is between these 2 points. So that's going to be 6 minus negative 3 squared for the y's, and 2 minus negative 3 squared for the x's. Sorry, I switched those up the other way, but that's okay. Addition is commutative. So 6 plus 3 is 9 squared, and 2 plus 3 will be 5 squared. So that gives me 81 plus 25. And when I square root that, 81 plus 25 is 106. So the square root of 106 is approximately 10.3. Okay, the second part will be between these two. So I'll start with the x now. It's up to you. 6 minus negative 3 squared plus 2 minus negative 3 squared gives us also 9 squared. And then 5 squared. Interesting. Well, isn't that the same thing? That is the same thing. Root 106, approximately 10.3. This notation isn't, there's a few different ways of writing it, so. Okay, so actually these distances are the same. That's interesting. Notice that the points here are just switched, but these 2 points are the same, so that's going to cause it to be the same. Okay, now we need distance 3, and distance 3 comes from 2 minus 6 squared and 6 minus 2 squared, and square rooted, giving us negative 4 squared plus 4 squared, which is 16 plus 16, so that's the square root of 32, which is approximately 5.7. So the perimeter is altogether 10.3 plus 10.3 plus 5.7. It's approximately 26.3 units long. Here's another example. Develop a formula for the diagonal D in a box with length L, width W, and height H. So that is a distance, but we've got 2 steps. So I'd like you to think about this for a little bit. Maybe pause the video, think about how you're going to set up your triangles so that you find the distance that is desired. So you could consider this bottom triangle here of width and length. So you could find, let's call this diagonal x, you could find that x, and that would be w squared plus length squared square rooted, right, by the Pythagorean theorem. So that's what x is. And now if we take that x and use it in this upright triangle, you would see that you would be taking, to find D, you'd be taking the square root of whatever x was squared plus what h is squared. That's an h. So you'd have the square of the square root of w squared plus l squared. But this square of this square root will make it cancel, so you'll actually have w squared plus l squared plus h squared, all under a square root. And now we have a new formula to use if we want to find the diagonal across a rectangular box. So, knowing that, find the length of a diagonal of a cube with side 5. So the cube is 5 by 5 by 5. So just like the length of that diagonal box, we want the diagonal in there. And we've already found that the diagonal is going to be the square root of the squares of all the sides from the previous example. So that's 25 plus 25 plus 25, which is 125, and so that's the square root of 125. You could approximate it by 11.2. You could also simplify it, and that would be 5 times 5 times 5. So that's going to be 5 root 5 as an exact value.